All right, I think we're live. Introduce
Okay.
to talk about how monitoring matters.
Yep. So this is a presentation I originally gave a kickoff, and there's an intended audience, which is sort of internal folks, and we were talking about why we're different with monitoring and what we do, and what's important to us. So I will proceed, hopefully. So the template, this is agenda template, remove slide, that's good. We want to talk about the numbers of what we monitor and sort of our philosophy, the tool we use, and a couple of case studies. I like this slide because I love doing PowerPoints because I like doing the transitions. That's the best part. So I have unique transitions, but something we run into all the time where we're doing a lot of complexity. I love this slide. Find X. So this is talk about me. I'll skip this part. And yeah, first of all, I like slide transitions, and we want to talk a little bit about why is monitoring more important and harder than ever to deal with, and why we're good at it. Why is it harder than ever? First of all, it used to be you could just ping things up, down, and you would know if something goes down because you just can't ping it. It was pretty simple. But now these networks are really complex, and things just very rarely just sort of ping down. They fail. They partially fail, different components fail, and they sort of linger on in a pained state for a long period of time. And if you don't fix things proactively before it completely fails, then the recovery process is actually a lot harder than it used to be when things were simple. Also, things like network storage, compute, security, the lines are blurring. So now, obviously, you have SANs, you have virtualization, you have things like call management with multi-master clusters, and they're all interdependent, and it makes it really difficult to monitor any one thing to determine its health. You really need to monitor everything. And the goal is to get you to believe that our monitoring system is no joke. Our monitoring philosophy and process is no joke, and we match up against anyone, and I mean anyone. And as I am, constantly getting people saying there's a million monitoring tools, and in general, engineers, especially if they haven't built the tool themselves, they don't believe it works. And on a daily basis, somebody IMs me like, hey, I got this great idea, but the other thing I got not too long ago is, hey, we should have a cloud monitoring service. Like, we are a cloud monitoring service, and we have been since the 90s. Just changed the marketing term changed out from underneath us. We mentioned that. So why we depend on monitoring? And this has to go with the cheetah theme. It helps us be faster and increase our uptime. So we can determine something that's broken, but a lot of times what's more important is that we know what's not broken. So if we have a customer call in and say they have problems, and we may not have detected, or we may have detected something, we can instantly rule out hundreds of possibilities of what the problem could be. Because we're monitoring it, we're not getting alerts. We know that where the problems aren't, and that's really underappreciated in terms of being able to eliminate a bunch of possibilities when you go down the fault sort of troubleshooting tree is really important. So it's sometimes not as much about what we see that's wrong versus what we see that's not wrong. But one thing is we have one tool that has a single view in every single customer. There's not, we have generally some smaller tools for troubleshooting, but we have one view into the health of all of our customers' networks, and that includes all the devices we monitor. So you don't have to go into 12 different things. And I mentioned this, we know what's broken and what isn't very, very quickly, very accurately. I was thinking this the other day, like our wireless at home, I have Cisco wireless gear, and we were having problems with the internet, and I'm like, oh my God, I wish we were monitored because I would know what was going on. I'm sitting there on the weekend on a Saturday, and the kids can't get to the internet. And I'm like, oh my God, I wish we were monitoring my home network, because I'm so used to depending on it that it's inconceivable not to have the information that we have at our fingertips in any situation. And I mentioned that who's our biggest customer in the previous slide, managed services. My customer is a managed services team as well as our customers. And it's our managed services team because our job is to give them information so that they can respond quicker, so we can reduce the costs associated with downtime and reduce the costs associated with having more people that are clicking through screens trying to figure out what the root cause is for problems. And the ideal goal is to actually be proactive. So we mentioned it reduces our mean time to failure, mean time to resolve significantly, and provides scale and process focus. This is important. I'll go into this a little bit later. We consolidate a lot of our intellectual property into the tools we use. It's not just my team entering in lots of data into the monitoring system. It's years and years of intellectual property and what is a problem, what isn't a problem, what alerts can be filtered, and then years of data that we've built into the system that basically says that we've built as a team to, in a real-world scenario, determine if there's real issues. So, an example of that would be if we have a major problem in a customer and we didn't detect it succinctly, or we didn't get the exact root cause or spelled out for us, and we go back, look at the real data, and figure out how we could have figured it out. And you can read all the guides in the world that are posted by Microsoft or any expert or VMware blogs, and it doesn't actually tell you what's important. And then this is a quiz I did. I have some quizzes spread throughout this presentation, and it's basically intended to illustrate how difficult this is to do on your own. How difficult to build a monitoring system and maintain it is if you try to do it yourself, unless you have a team focused on it. So there's a question is for memory and disk on a device, how many bytes are there in a megabyte? A lot of people say, 1 million, but it's actually a little bit more than 1 million, because bytes on a disk is 1024 by 1024. A kilobyte is 1 byte times 1024, whereas on a network, if you're looking at megabits, a megabit is 1,000 bits, but in storage it's 1,024 bits. And the other thing is how much bandwidth do you get through a T1. Everyone knows that's in the networking thing that they'll say it's 1.544 megabits per second. You get a T1, but it's not right. It's 1.536. And we know this because NOS models the tool we use models the actual speeds of the interfaces and does a percentage calculation. So if you think it's 1.544 and your monitoring system can't discover the speeds, then you're going to be 5% off, which doesn't seem like a lot, but if you have every bit counts. Some numbers. These numbers I'm going to say a little bit out of date. We've numbers. There's a bunch of famous quotes about this. Numbers mean what you want them to mean. But these are roughly the scale is roughly equivalent. Some of the data we actually realized we're getting a lot more data than we thought we were previously. So, but we pull something on the order of 500,000 data points right now every 5 minutes. So that's about 140 million data points per year, per day. And there's about 60 billion data points per year. So reliability is really important. We process we get about 230 external event alerts per second. So those are devices sending us things, events and information about what they think is going on. And so we have 230 chances per second to make a mistake, and 230 chances per second to have instability. And that is something like 7 billion a year. What we found actually is that this is actually way underestimated. we're actually filtering out at the edge of our collector over 1 billion alerts per day, believe it or not. And so we're a little bit off by, I don't know, order of magnitude. One thing that people ask me, how many devices do you monitor? Even simple questions like this are really difficult. Just to illustrate the complexity of monitoring. But roughly these days, we're about 30% Cisco network electronics devices, routers, switches, things like that. About 30% servers, including VMware hosts, just servers, including UC servers, call managers. We're about 20% VMware. But the numbers are really difficult to calculate. Just getting a good inventory is very hard, and it's something we do well. If you think about it, you can have one SQL server that could be multiple SQL instances. So how many things you're monitoring a SQL server? It could be 3 SQL instances, it could be 10. But do you count that as one SQL server or 10 SQL servers? Wireless LAN controllers, like one wireless LAN controller can support hundreds of APs. But right now, for example, we have something like 30 wireless LAN controllers we support, but it's like 500 wireless access points. And, we have maybe 500 VMware hosts, but that counts for thousands of little pieces within VMware. And, if you look at the phones we monitor indirectly is tens of thousands. And even things like Cisco switch stacks, sometimes there could be 5 switches in a stack. We monitor as one, but there's 5 physical devices. So the numbers are, just getting inventory is difficult. So what is our philosophy? Our philosophy is non-actionable events are evil. Some people call non-actionable events false positives. I have a different view. A false positive means that a false positive basically means that you have a piece of data that's not useful. There's very little of that. Every little piece of data is useful, even if it's bad data. It tells us that there's something buggy on the other side. So we say non-actual events. That means we get an event, our NOC watches the events 24/7. They watch an event console. If they get something that they can't do anything with, it's not ticketable, or it's not giving them information they need to check, then that needs to be trimmed back. And as you imagine, receiving 130 per second, we do a lot of that. So the other people say is how come you have people looking at it? They make mistakes. It's because the more you alert in false positives, the more non-actual events you send to the customer, the less valuable the alert data is. We can automatically send every event we get to every customer, but computers aren't very good at picking out certain types of patterns, and that's why we don't have robots running around doing our jobs right now. Computers aren't very good at matching patterns. The human brain is really good at certain things, and one of them is sort of putting together patterns and establishing relationships really quickly and really efficiently. And they just can't do things. And what's more important to us, for most of our customers, is that we give them information that's actionable. And I would say that even at the expense of missing some things due to human error, it's much more important to get 99% accurate information and worry about the 1% you miss than to send a glut of information where 95% of it is not actionable and 5% is actionable and miss nothing. If that makes sense. So our philosophy is that we receive a lot of data, and the vast majority of it doesn't get used. But when you need it, you really need it. So we store a lot of data, but our philosophy is, for the most critical things and things that require proactive action or reactive action right away, that's the stuff we send to the NOC, and they'll alert the customer in real time or semi-real time. Everything else, what we try to do is we try to catch things like capacity planning and things like that. We try to run reports on that stuff where we're reviewing the data with the customer on a regular basis, usually on a monthly basis. We're saying, here's all the information that we didn't send you in real time, but it is important. that needs to be dealt with. It just didn't need to be dealt with right there, because we don't want to interrupt everybody's daily job. There's always problems. There's millions of problems constantly, but we want to make sure that those things that aren't immediately important get added to the list and not forgotten. The idea is, so we filter all this information so the NOC gets the real-time stuff, but the rest of it we report on to deal with. Some of that stuff actually happens on a daily basis, where we review certain things like backups. Those don't need to be, we don't need to tell every customer every backup job failed right away, but they need to know daily that a backup job failed. So the backup jobs wouldn't go to the NOC saying, hey, a backup job failed, a backup job failed. That's something where we collect the data, and then on a daily basis, we review the backup data and we send the alerts to the customer. We collect other events just because sometimes it's useful. Like, just because the alert's not critical doesn't mean it's not important. Sometimes informational warning events lead up to giving you the source story of why something is going wrong or what happened. So we collect a lot of data to try root cause. And again, I said, like, you don't need all these stats until you really need them. And we had a situation with ACS not too long ago where a couple of years ago, I spent like a day and a half putting all these stats in for latency on certain types of VMware devices. And I was asking myself, is this even worth it? And like, a year and a half later, we had this major weird buggy bug with EMC, and we wouldn't have caught it if I had spent that day and a half 2 years ago putting the data in. And that, so it paid off. That day and a half would have been a lot more man days of engineers trying to figure out what's going on, and as with regular reports. The other thing that's really important is that a lot of people, they'll just rely on external alerts, so like traps and syslogs and logs to tell you what's wrong. You can't do that. You need to pull the most important data. So every 5 minutes, you need to go and ask the device if it thinks it's sick or healthy. And you also need to have the external alert sent to you, because there's tons and tons and tons of bugs out there, vendor bugs, and there's lots of things that can go wrong. And you need multiple layers of redundancy in your alerts to be able to catch the most important things, even simple things like a bad hard disk. It's very possible that, and we've seen this many times, where you go to pull the disk and it says it's healthy, but then it sends you a trap or an alert saying it's sick. And we built a library of these things, and some of them we actually go through and identify bugs. So we'll say, all right, well, this is saying it's sick, this is saying it's healthy. We know it's really healthy, or we know it's really sick based on experience. So we do both. We pull and we receive alerts for the critical stuff. So we have redundancy built in. So all the stuff we're talking about, what happens is people say, yeah, these things sound great. We should all do this. So let me just buy a tool that'll do it for me, right? That's great. There's lots of tools that'll do it, and I go into that later. But that's not going to get you what you need to get. What you need to do is do what we do, which is every single day we collect the real-world data, we constantly tweak the system, we measure our accuracy. So we actually, and I show this on a slide later, we actually measure how accurate we're being, where we measure how many events we get versus how accurate we are. We relentlessly reduce non-actionable events, and we provide great flexibility and accuracy for our customers. So we can really, our tools, our process makes it so we can very, very quickly customize and adapt the system for our customers' needs. A lot of other systems out there just aren't as fast and customizable, and you need to be fast and customizable, especially fast these days, because everyone's needs are different, and the technology changes so fast, quickly. Did I say fast again? Humans have to do this. There's no monitoring system in the world that's going to adaptively make all these decisions for you. What you have to do every single day is make it a priority and go in and tune things, not only for the systems that you monitor, but for the customer's needs individually, and that's what we do. If there's a non-actionable event, and it gets escalated to an engineer, and it's not something they can deal with, and they let us know, and we tweak the system back. The command centers, we're constantly working as a team to provide feedback to make the systems and the data better. We do it every single day, and that's what most people aren't willing to do. Most people are looking to buy the magic tool. There is no magic tool. There isn't. and we work by meaningful reporting. So not a data dump, but information that has some intelligence. Like you don't really need to report on every single interface if none of them have errors. Things like that, basic things that you think were basic and aren't. So this is a rough illustration of how I mentioned we measure ourselves. There's a rough illustration in sort of chevron format of the technology and the people and what the effect is on us reducing the number of non-actionable events. So roughly, if you have 20 million raw events, those are events that come in, those are events after they get filtered by our collector. We take on average 20 million of those, and we'll save that. We'll store about 15,000 of those. This is roughly a day's worth of data, although this has changed a lot recently. So we reduced, right off the bat, we reduced 99.9. We reduced the number of events from that down to 99 by 99.925%. Then the events that are stored, about 1.5 thousand are actually reviewed by the NOC, and that turns into somewhere between 50 and 100 tickets per day. I had a slide with a total reduction, but it's in the 5 nines in terms of events that come in that go through all of our technology and people filters into actionable events. And again, this stuff doesn't happen by accident. It's not that our tool does it for us. It's that we focus on it. So I mentioned, this is what I get a lot. Hey, Doug, what? Hey, Foss, really need a tool. We should totally use it. Dude, it's 2 a.m. Then why are you still awake? Stop bothering me. I get these things all the time. There's always a tool. And when you deal with tools, there's 2 ways to go about it. You put one tool in that can view everything. And you weren't really able to do this until recently with some of the newer monitoring systems and technology. It wasn't really doable. But so what people do is they'll put in one sort of event correlation system that overarches everything. And then they'll put in lots of little mini tools underneath it that feed the event correlation system. And that is super problematic because it is very hard to maintain just one system, never mind lots of them. And then having to have multiple servers and components feed into an event console, there's a huge amount of error involved with that. So integrating multiple monitoring systems is very difficult. I would say it's impossible. If you really want to view a consolidated view of what's going on. And I think that's super important to have one view as to what's happening. All the events are in one place. All the information is in one place. Get out of the way. There's a million. We use Xenos as a tool. I didn't mention Xenos really much till here, but yes, there's a million tools that are better at any one thing. But there's nothing that we found that's better at consolidating them all at the speed we need to consolidate them and move at the speed we need to do. So those are my exaggeration, hype, and lies because we've done multiple this is our 4th monitoring system we've had, I think, since I've been involved in NWN. Third or fourth. It's our 4th one. We've evaluated them. We've seen different versions of everything, but as we get a lot in the marketing speak, automatically maintains up-to-date data map. No, there's nothing that updates a data map. It doesn't exist. It requires human intervention. Exaggeration. Automatic smart correlation. Exaggeration. Better than traditional tools because it simulates actual human exaggeration. People say, hey, what's important is do real simulated logins, and you just can't do it everywhere. It's not the answer to do it. The answer is to replace your monitoring system with a tool that does synthetic transactions and mimic what a human can do because it's too complicated. It doesn't work. Insert anything cloud hype. Choose, next generation tool that inspects it. There's other tools say they inspect the actual network and determine patterns. Hype and lies. If we had people growing on trees that could look at packets growing over networks and figure out what was wrong, then life would be easy, and we wouldn't be calling this stuff we do technology. We'd be calling it, refrigerator sales or something like that. Has all the built-in thresholds, lies. That you look at something like Microsoft Operations Manager. Any one of these tools is good for what they do, but like they have all these tools and counters built in, are very Microsoft specific, but none of them are tuned. You have to go in and tune them. It doesn't matter what the tool is; it has to be tuned. It doesn't matter how good it is, and it's really hard to tune. I would hesitate to guess if you do something like Microsoft Operation Manager, it's going to be terrible at doing Cisco stuff, but really good at doing Microsoft stuff. But you need both. Out-of-the-box reporting, that's the worst lie of all. There's no out-of-the-box reporting. So there's a Xenos little screenshot of the tool, use a big old Nexus switch. So why? When somebody starts the conversation with the words, can we monitor? The answer is yes. But just because we can monitor it doesn't mean we know how to. And what I mean is that you can't monitor a device unless you understand how it works and what's important. We can monitor Oracle databases like a champ, but we don't have Oracle DBAs. And without Oracle DBAs that have deep experience in Oracle, even if I and my team can figure out what to monitor, the events aren't going to be actionable. The hard question is, does it have enough value for the customer to monitor it? And how much monitoring is enough? Because you can do a lot or a little. Those are the harder questions to answer. But if you come up and say, Doug, we have this weird system, if I'm telling you, if it can be monitored, we can do it. And if it's not out of the box, we can build it. And we can build it way quicker than any vendor can build it. I built a Dell Equalogix monitoring tool, over the course of a month at night. And it mimics this tool that Dell wrote, and I'll guarantee you that they spent hundreds and hundreds, if not thousands of man hours building it, and I spent probably 100. No, not even. I probably spent 20. So we can build monitoring ourselves if we need it really quickly. A quiz. This is sort of technical, but you purchase a 10 megabit per second. You purchase a 10 meg connection to an ISP. How much bandwidth do you have in bits per second? Normally, a lot of times you get 1 megabit per second, but in actuality, most of the fiber providers give you megabits, which is slightly different. It's about 5% more. And again, we can detect that, but a lot of monitoring systems can't. And we actually update it on every 12 hours. We rediscover everything. And the other thing is, like, your Linux server stops working. It says the disk is full. But you go to the server and what's up gold, or insert your random operating system monitoring system here, and it says you have 5% free. Why are you out of disk space? The application is saying you're out of disk space, but you're not. Well, the answer is most Linux distributions and Unix distributions even, they only allow non-root users to see 95% of the total disk. So most Linux distributions, you run out of space at 95%. The answer is, can your monitoring system handle that? And the answer for us is yes. So what we do, you can do it a few ways, but the way we do it is we reduce we inflate all the disk pulling by 5%, so it actually returns a value of 100% used, even when it's only 95% used, just because it's easier to explain that to people than it is to say you're out of space and it's 95% full. But you can do it several different ways. But these are all little picadillos that you deal with every single day. Another one of my favorites is temperature. Like most vendors use Celsius except for Emerson, which does Fahrenheit, which is fine. But then you get like Dell servers, and when you go to read a Dell server Celsius temperature, it gives you in hundredths of a centigrade. It's constantly like that. Like you just go to pull a data, and you think you're getting, the data, and one vendor decides to give you 100 times that, and the other one gives you 1,000 divided by 1,000. So why Xenos? It's all in one place. That is super important. We get it all in one place. we monitor more things in one place than anyone. Another reason why is Xenos. One inventory, so we have you can view your inventory information in the same place you view the monitor. We automatically rediscover inventory information on most of the devices we monitor every 12 hours. One of the big challenges of a lot of these monitoring systems is somebody will go and swap out one router for another router, and the monitoring system still thinks it's the old router type and it's changed, but we automatically rediscover this stuff because things change at a rapid pace on our customers. They always let us know when they make changes. Flexibility is super important, and speed. So a lot of times built on a programming language called Python, which is really ideally suited for dealing with network administration and stuff. And so we can make changes very, very rapidly using this programming language, very, very flexibly, and multi-tenancy. This is another thing. When people come to me with a monitoring system, we're considering it. One of the big issues is multi-tenancy. We have customers with duplicate IPs everywhere. We have 100 customers with a router named Boss Core, Boston Core. You need to be able to be multi-tenant, and you also need, a lot of the monitoring systems don't do multi-tenancy well. They don't scale out well, and they can't separate customer data and in a secure way, and you have all kinds of weird issues that will pop up if you try to force that in there. And the other thing that a lot of monitoring systems don't do is you'll be bopping along and all of a sudden find you're not monitoring something at all. And you'll go months not knowing. I've seen it. And one thing that Xenos is really good at, and we're really good at layering on top of, is telling us when the monitoring itself is broken. So the device may be up, but we can't get statistics on it. That's super important and very, very challenging, and most systems can't do that. We have thousands of devices. We can't just go and manually review whether they're all monitoring every 5 minutes. It needs to be automated. So this is basic architecture, the way it works. On the upper left, we have an Oracle MySQL database cluster, and then we have a master server, and then we have the end users talk to the master server to get their data, and we have these hubs which distribute out the connections to all the collectors. We generally put collectors at client sites. We have some back here that we pull data over the internet for, but the collectors are distributed. So we have, a lot of collectors out at different customer sites, and it's not really a scalability thing. One collector, if you make it big enough, can pull lots of things. Where you put a collector is highly dependent on what you want to monitor and how. And we work with the ASC and the customers to figure out how we want to monitor things during the enablement process. So, and it's all based on Linux, not a super Linux bigot, but as you can see, like we have collectors that we can keep a Linux server patched and up for years. Where the operating system really isn't ever the issue. It's always the applications. It's very stable. There's reasons for that. Why Xenos Cisco support? They've built. I mentioned we can build monitoring software. They focus on building their own sort of add-ons. They're called Xenpacks, and where they've been focusing is really in line with our technology mix, which is heavily Cisco on the networking side, and they support more high-end device. A lot of these high-end devices we deal with, Nexus 5Ks, ASRs, all the way from the big stuff to the little stuff. The other thing that's really important is the model. A lot of monitoring systems don't understand the interrelationships between the different systems. They may have some capacity to do that, but when you go to build a model of a device in Xenos, you're building an actual model of the object-oriented model of what the device looks like, which lets you sort of hook things together. It's kind of a deep discussion that I could have separately. But the other thing this is a screenshot of a product that we actually don't use right now, which is called Impact. This is more of a next-gen type of thing where you can build a service map of all the little bits and pieces of your network, and put it up in a hierarchy, of a tree hierarchy, and so you can determine the health of a particular service you're offering a customer in all the dependencies. So in other words, if you look at the bottom, you'll see in the bottom, very bottom right, there's a disk there. Just because one disk fails doesn't mean that the whole service fails. If that disk fails, it may go red, but the service may, as it goes up the tree, different parts will go yellow. So this is technology that we're looking to put in for our NCOM service offering, or hosted voice services, because those systems are really complicated. And if you can build a service tree, if you can maintain it, then you can very quickly spot where problems are, and you can use, and you don't need like 20 CCIEs sitting in your NOC to determine the root cause. You can distribute you can have lower level people making higher level decisions very quickly. But the price you pay is that you have to maintain that service model. So you have to be asking, and you have to be involved with the discussions that happen. You have to have a seat at the table, the same seat at the table that a security guy may have in internal IT discussions. So, part of the reason why we haven't implemented is that customers aren't willing to invest the capital it would take for us to be ingrained there. We can do it, but are people ready? Another question is that what's practical? I want to alert on PRIs, but only every other Sunday, but only for PRIs at even numbers and interface names when we use more than 20 channels. Or I want you to discover all my IPs on my Nexus, but I'm not going to give you admin privileges. Or I want to be alerted every time I get an interface error for all 50 MPLS lines. I'll steal the thunder. Most people are going to say B or C. What's reasonable? Most people are going to say B or C, but the answer is actually A. It's a little bit of a trick question. One, you can't discover IPs on a Nexus without admin privileges. It's just not the way. Unlike every other Cisco device, you can't. And C, you would not want to get an error alert every time you get one error on 50 MPLS lines. You go crazy. So A, I can actually do that with Python in a few minutes. And we actually had a request that's very similar to this for a big customer recently. And, this would only work if you could do this, enter your harebrained scheme. And I'm like, oh, yeah, I can take care of that. When do you want it by? No problem. So there's just another little screenshot of this NetApp file system. You can see the model. It shows how the things are interconnected within the device itself. And when we build a Zenpack or Xenos does, we build the interrelationships so we can see how they all roll up. There's another screenshot. This is a voice gateway. And you can see on the left all the green things. Those are all the individual components of the voice gateway. A lot of those we've built internally because we have, if you look around the sort of world and look to see who's built voice monitoring software, you'll find very few examples. And we had to build a bunch of custom code to monitor voice gateways. In this case, it's actually monitoring PRI utilization, which is very hard to do, and a lot of people think they're doing it, and they're doing it wrong. And we can do it here. We can see everything here, and if you're technical enough, you can see where voltages. The one thing that they didn't introduce here is that IPSLA, which we can monitor automatically too. So one thing I mentioned about is proactivity. You can install any monitoring system from WhatsUp Gold to your most complex BMC implementation, and with very little work, get information about what happened after the fact. It's not hard to have a monitoring system. It's still hard, but it's not super hard to be able to use a monitoring system as a reactive tool. It's very hard to use a monitoring system as a proactive tool because you have to be willing to send alerts and trim them down to a NOC before things are actually down. You have to be willing to allow a little bit too much in to your NOC and let the humans make the determination as to whether there's a problem. And this is something we really work hard at, is trying to determine problems before they get fixed, before they become real issues. But interestingly enough, is a lot of times not the technology that's the barrier there. The barrier is people, because everyone's so wound up. Everyone's used to reacting. And I can't tell you how many times I've said, hey, something's going wrong here. We should implement new preventive maintenance, or we should fix this before it becomes a major issue, or before you have a major issue and you have to fix lots of little things to get to the root cause. So what happens often is it will send an alert in, and there'll be stages of denial. And this doesn't matter if it's our engineers, customers. This even happens to me when I implement a new alert. Like, seriously, I'll put something in and I'll be like, no, this can't be right, because it's something I manage, and then I eventually sort of come to accept it. But, you know, this goes from, there's a desperation scale from not very desperate to very desperate. The first one is, so what happens is, send an alert saying, hey, power supply's dead. And somebody will log in, it's the middle of the night, and say, I logged in, it's up. So it's not real, right? It's not a real alert because it's up. Well, you didn't hear what we told you. It was a proactive alert. The power supply's down. The device isn't down. And sometimes you'll go in there and it'll say the power supply's not down when it really is, or the monitoring says it is, and the console says it isn't. Then we get, so then once you say, no, the device, it's not the device, it's the power supply. Then you get, well, those errors are normal. It happens all the time, so it's not worth action. It's not worth me taking the time to fix, because it happens everywhere. And with us, the good news is we have everything in one place. So, and we have the inventory information integrated with the alerts information. So I can really quickly, in a couple of clicks, say, all right, well, that's funny, because we have 13750 stacks, and this is the only one that has that error. So it may not be the power supply's down, but it's certainly either a monitoring bug on Cisco's side or the power supply's down. And you can never do that unless you have scale. Scale is important. You need lots to get good at monitoring. You need lots of things. You need to see lots of failures, and it's really difficult unless you have a really big network to be able to experience enough failures with enough different devices to trim your monitoring system. You need that scale. And I was telling Skip the other day, we get better the more we do. And we're the best at the devices that we have the most of. Then the other thing with them is it's a bug. It says NOS bug, or name your monitoring system. It's going to be a bug, right? And you say, no, it's not. It's not a bug, because I'm going to manually SNMP walk, and I'm going to manually get the data off the device and see it's still there. It's still a problem. And then the last sort of phase is it's a false positive, which means I'm so busy I can't deal with it. But this is happens. So the bottom line is people, and then eventually people accept it. The bottom line is people aren't geared to fix things proactively when you're dealing in a world that is, rewards the reactive over the proactive. Proactive is harder. And if you look at all the studies too, there's I'm going to quote Skip Tappan, our COO. I'm sure you didn't come up with this original idea, but there's this sort of a matrix of things in the upper right that are urgent and urgent and critical, and then there's the things that aren't urgent that are important. On the other side, the best people, the best organizations can deal with things that are important but not urgent. Everyone can deal with things that are important and urgent. And in fact, I go and meet with customers all the time. They'll say, hey, when there's a failure, we all rally and we fix it. We're really good at that. And I think, well, you've already failed. There was a failure. You didn't know about it, and now you're rallying. And everyone knows how much, everyone with any business experience knows how much more it costs to react to problems versus solving them up front. Everyone's good at fixing things when they're down, right? As long as you have good people, you have that. But you need good process, technology, and people synchronized to fix things before they become issues. So some case studies. Cloud data center alerts. So this is a situation. We got a huge cloud storm from a data center that has cloud information. The symptom was the storage get disconnected, but then the storage reconnected. It took a long time for the systems to come back online, long enough where it caused major issues. Why? So, with any other monitors, we saw it was easy in the individual tools to see that the storage disconnected. It was easy in the individual tools to see. If you go into VMware, you saw VMware saw an alert, and if you went into storage, you see that it was a cause. That there was definitely a storage bug of some kind. but why did it take so long to reconnect? And we figured it out. And basically, you can't really see this alert, but we had one view. And when this type of thing happens in a cloud data center, there's hundreds of pieces of information, hundreds, because there's all these repercussions from the storage being unavailable. But basically, because we have everything in one place, we basically just went into the console, filtered on this particular customer really quickly, like 2 clicks, and sorted by the time, and just went through it. 1, 2, 3, 4. First this happened, then this happened, this happened. What we noticed is that there's these virtual Nexus switches that run, and this isn't a real switch, it's a virtual switch that runs on VMware as a VM. It had a bug where if it was logging to a virtual disk drive, and what happened was the virtual IOS couldn't handle an interruption in the storage when it was logging, so it crashed. So what happened is the storage went down, then these virtual switches crashed, and then they took a long, like 10 minutes to recover themselves. So, boom, we figured out the root cause of something that really, really complicated that could have taken days, if not. A lot of times you would never have known the root cause, because if you think about it, the logs, this Nexus switch, it was trying to log. The logs were gone. It couldn't write the logs. They would have been lost forever. But instead, we actually got the logs, went through it, and we saw that, all right, first the storage failed, then this switch crashed, then it came back on, and then 10 minutes later it came back online, then VMware came back online. So we were able to figure out what it was and prevent it from happening again. Here's another thing. This is a little bit difficult to explain, but basically on voice gateways, there's these little, basically you can think of processors that deal with offloading things like compressing voice brackets and things like that, and they're called DSPs or PVDMs, depending on who you talk to. And like any other component, they're little chips, they can fail. This is an example of redundancy we've built into the system that where we monitor the most critical things multiple different ways. We got one alert to the right, which was a trap saying the DSPs were shut down. And then we get another alert to the left, which is a syslog saying it was resetting the DSP, and it got an alarm notification. And then we get another alert from our polled system that basically said that the state changed from up to shut down. Now there's 3 states. There's 4 states. There's unknown, up, shut down, and failed. We know, because we monitor lots of these, that shutdown doesn't mean shutdown. Shutdown means failed. So because we got information from syslog, we got information from traps, and we pull the information, and we'd seen it before, we wrote into the alert that basically shutdown means failed. So here's a piece of information. You got it. We actually wrote the alert into the system to say, hey, shutdown has failed. Shutdown isn't shutdown. What happened in this case is we actually saw it late in the day, and some of the DSPs failed, and it was a little bit off peak hours, and we actually called Cisco and had them show up and swap the parts out before there was any outage. So that was not monitoring. That was the NOC saw the alert. They knew how to escalate it. The ASE got the information, digested it, made a correct diagnosis. The NOC, fed back to NOC. The NOC got a hold of Cisco. Cisco was in sync with us, and underlying all this, the technology team and the ASE team in the past had seen these issues, and we worked out a plan that was automated to differentiate a shutdown from a failure. And the bottom line is that the customer we found a problem before it caused a customer issue. And this is it getting fixed. And then the other thing we do is it actually cleared because the polling said, yep, it's good. So then the other thing that happens a lot is that people think they fixed something and they didn't, because the alerts just sit there, and we actually have it set up to actually clear and show it good, so the engineer could watch it and make sure it actually solved the problem. So, and then I called call to action. This is for people. So, position it. Don't sell a tool, and don't sell other people's. Don't sell. If you have a monitoring opportunity, present the customer with a better option. You know, they can't. Nobody could put a better monitoring system in a reasonable amount of time than we can deliver. You know, standalone. And what we need is people to understand how good we are at this, and that it's not just about people. It's about people, process, and technology and experience all melding together to provide this service. It's not. You can put all the smart people in the room, but if you're not working together, it doesn't work. And you know, don't give away our intellectual property. If we're out selling standalone monitoring systems or putting in other vendors' products, we're sitting down and putting this in for the customer, and we put it in once, and that intellectual property is gone. We could take the same amount of time, put it into customizing our own monitoring and making it better for our customers and you know, advantageous to us, and contribute. We need technical advice. I don't need people, like what I don't need is, hey, here's a great tool. What I need is, hey, this is how we should monitor this, or this is what this tool does well, we should emulate it. You know, that's what the information I need, we need as a team. And then the other thing I mentioned is there's opportunities. Because we can monitor anything, and my team can't do it all, like we can monitor custom applications for the app dev team. We can monitor things 6 ways a Sunday. They all take work to put in, and I would love it to be able to have a professional services arm that can develop these solutions for customers. You know, whether it's our RPS, our organization doing it, or offshoot us. So again, this is the last slide. There's no time left because I can't shut up. And you can contact me, call me, link me, only email me if you don't expect to get a response. So that's my presentation. You guys still there? You're asleep?
Still here. I just shut off the recorder.